A machine in southern France is being built to hold matter hotter than the sun, without touching its own walls. If it works, 50 megawatts of heating could trigger 500 megawatts of fusion power inside the plasma. That sounds like the future arriving, but the hardest part is not making fusion happen for one perfect moment. The real problem is turning a tiny artificial star into a power plant that runs when civilization needs it. Fusion is not another battery, turbine, or solar panel. It is the engine that powers the sun. Inside stars, light nuclei are forced together until a little missing mass becomes usable energy. Einstein's equation explains the trick. Mass and energy are two forms of the same hidden account. On Earth, researchers mostly chase deuterium and tritium, two heavy forms of hydrogen that fuse more easily. When they fuse, they make helium, a neutron, and the burst of energy engineers want to capture. But stars have gravity, machines do not. So Earth must cheat with temperature, pressure, and control. The temperature cheat is almost absurd. IDR plans plasma at 150 million degrees Celsius. That is about 10 times hotter than the sun's core. Inside a building, humans can walk around. No wall can touch that plasma. The fuel must float inside invisible magnetic fields, like lightning in a bottle. That is why a tokamak looks like a metal donut, but behaves like a magnetic cage. The plasma races around the ring, while superconducting magnets squeeze, steer, and keep it away from everything solid. If the cage slips for a moment, the star does not explode. It simply cools and dies. That safety is one reason fusion is tempting. The reaction needs extreme conditions to keep existing. But the same fact creates the nightmare. The machine must recreate impossible conditions again and again. ITER is the largest attempt yet to prove that magnetic confinement can cross a crucial threshold. 34 nations are collaborating there, not to build a power station, but to answer one question. Can a plasma produce far more fusion power than the heating power used to start it? ITER's target is Q equals 10, 500 megawatts of fusion power from 50 megawatts of heating. That would be historic, but ITER will not sell electricity to anyone's grid. It is a bridge machine built to teach the next generation what a real fusion plant must survive. Because plasma gain is not the same as plant gain. The building around the plasma still consumes power. Commercial reactors must be simpler, tougher, cheaper, and useful outside a laboratory schedule. A second path does not use magnetic cages. It uses violence compressed into a microscopic instant. At the National Ignition Facility, 192 lasers strike a target smaller than a pea. In December 2022, Lawrence Livermore announced fusion ignition and later said it had repeated it. For the first time, a laboratory fusion shot crossed a symbolic line chased for decades. But laser ignition is also not a power plant. One beautiful flash is not steady electricity. A plant would need targets, lasers, heat capture, and repetition, working with brutal industrial rhythm. So fusion now has two stories at once: scientific breakthroughs and the quieter problem of machines. The public sees ignition, engineers see neutron damage, heat loads, fuel cycles, magnets, and maintenance. That gap between headline and hardware is where most fusion promises either mature or disappear. This is why private fusion companies matter now. They are trying to compress the bridge into decades. Commonwealth Fusion Systems says its RC plant could reach the grid in the early 2030s. The company says RGE would deliver about 400 megawatts of clean power to the electrical grid. It describes RC as familiar to grid operators like a gas plant without carbon dioxide emissions. That claim is powerful because grids do not only need clean energy, they need energy on command. Solar and wind are essential, but they rise and fall with weather, daylight, and geography. A working fusion plant would be different: dense, steady, compact, and potentially built near demand. Commonwealth says fusion fuel has far greater energy density than coal, and even greater than fission. That is the dream: enormous energy from tiny fuel, without smoke and without carbon dioxide at the stack. But dreams do not connect themselves to the grid. They need permits, factories, supply chains, and trust. They also need proof that components can survive years beside a star trapped in metal. The honest answer is still uncertain. fusion is closer than myth, but farther than a headline. If it succeeds, humanity will have learned to power cities with the oldest fire in the universe.